Am I recording? Yeah. So I knew I was risking getting myself in the weeds by bringing up vectors so early. And there are some rounding errors that make the answer not exactly, like it seems like it's not going to work correctly because it's going to look like I'm off by a couple decimal places, but the math is 100% correct. There's some rounding errors. There will be some errors that are caused by rounding when I rounded these values and divided by rounded values. You guys know how significance figures work in theory, right? You know if you round off decimals and then start multiplying and divided by your rounded decimals, your answer gets more and more off. So when I do it the vector way, which is 100% a valid way to do it, it's going to look like the answers are only accurate to the first decimal place. But if I hadn't rounded this, they'd be the exact same answer. Here's the idea. When you have a velocity going up a hill, if you think about a velocity moving in a specific direction, a slanted direction, you can think about this direction being a combination of a horizontal direction and a vertical direction. The way it was explained to me when I was a kid was like if I had a round box, this is a bird's eye view, and if I had one friend pulling really, really hard on the box in this direction, and another friend pulling not quite so hard on the box in this direction, but this guy's pulling this way and this guy's pulling this way, then the box is going to move in this direction. So any slanted motion can be broken into a horizontal and vertical component. And vertical and horizontal components are nice because then we always have these right angles, and when we have right angles we can use, basic trig stuff to figure things out. And so the idea is if this, whatever they hoist up this hill is being hoisted at 300 feet per minute in this direction, then we can figure out that vertical component by just using what we know about right triangle trig. So essentially what I'm going to do is set up a trig ratio with my hypotenuse being this time the velocity and my angle still being that angle of 35.4 degrees. So that'll look like, well, I want to know this vertical component, which is the opposite side, and that's my hypotenuse, so I'm going to say that sine of 35.4 degrees equals, I don't know what that vertical component is, but I know the slanted component is 300. And then, so we'd write 300. And then, so my final answer will be whatever 300 times sine of 35.4 is, which is approximately 173.8 feet per minute. So the same answer now, when I did this on my calculator, it was 0.784. 0.78, yeah, 0.784. And when I did this twice with this calculation, I had 7.803. So, but again, that's because I rounded this. This had a bunch of threes after it. If I'd left them in there, this would have worked out perfectly. So I don't, if that's not making a ton of sense, that's okay. Like, that's a physics class. You'll take physics, you'll learn about vectors, and when you learn about vectors, all this fun trig will come right back at you, which is great. Great chance to practice, really. I sound like I'm being sarcastic, but I'm not. So anyways, hope that's helpful. And if not, hopefully the D equals RT way works. And if not, we'll just keep at it. We're going to figure it out. Be safe.